do pole dancing, I do aerial arts, and so I try to exert control over my environment by fighting with gravity. I'm fundamentally interested in just how do we represent the complex physical world to a computer so that computers can help us understand what in the world's going on around us, and so we can use our knowledge to enable different types of technologies to better humanity. I wanted to become a physicist, specifically a particle physicist, since middle school, which is kind of a weird thing. But I got really interested in the Large Hadron Collider, was going to come online as I was growing up, so I'd read everything I could about it. And then ultimately went to undergrad in physics. But then I realized that, things were really well on their way in particle physics, but there was also a lot of things to figure out at a medium scale, at the level of atoms and materials. And so in grad school, I switched to that. And then I realized there's actually a lot of problems with modeling just about any length scale. And that's how I got interested in machine learning, to try and attempt these problems. Right now, we're seeing that the types of models we build are actually starting to be used by pharmaceutical companies to better model interactions between molecules and proteins, and that's really exciting. But it really takes a whole community to go from designing these types of models to getting them into production to actually seeing can they help impact things in the lab and then get that all the way to clinical trials. So to be seen if we can help in that avenue, but that's one way. And then other ways is that we can try and help do this for materials design. So we have a lot of needs for low power electronics, better energy solutions, and so the hope is that maybe we'll have some impact there. A key thing in research, and this is something that I try to help my grad students through, is that research is always going to have ups and downs. We're doing it because it's hard, because we don't know the answer. And so sometimes it's just really important to step away from the problem for a little bit and do something else. So I really encourage my students to have a life outside of research, because we need to live well-lived lives, because we don't actually know whether our research is going to work. So personally, what I usually do is I usually hit the gym or do various other physical activities upside down. So I'm either lifting weights or I do pole dancing, I do aerial arts, and so I try to exert control over my environment by fighting with gravity. One level of advice is that it's really important to understand other people and what are their motivations and what are their thought processes for how they solve problems or why they're interested in things, but it's also okay to have a bit of a different opinion, that you can still celebrate what other people are interested in and their points of view, but it's also great to kind of own your own perspective. Now, you still need to verify that perspective with experiments and data, so you can't totally live off in your own land, but it's actually crucial to kind of bring your own perspective to research and life, and we really need as many perspectives as we can get for solving hard problems.